Geometry, Unit 4, Section 5, angle, angle, side, triangle congruence. So we're also going to cover hypotenuse leg triangle congruence. And these are the last two. So we've seen side, angle, side, 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 and now we're going to add two more, and that's going to bring our total list of ways to prove triangles congruent to 5. So angle, angle, side, different than angle, side, angle. When we had angle, side, angle, it was two angle congruencies and the side between. Well, what we're saying now is we have two angle congruencies and the sides not between them. So again, I know you're working on a piece of paper and you can't slide these things around like I can. That's one flaw here. But I do want to show you that I'm going to try to, I know this angle measurement and I know this angle measurement, and this is the one side I'm going to keep a fixed length. This side down here, I can, bring this together and I can make this longer. I can make this a really short side. So this side I can change and this side I can change. The things that are fixed here are these two angles and this side. And notice that that's why it's angle, angle, side, not angle, side, angle, because this side that I know for sure is not between the angles. And what I'm going to attempt to show here is that given this angle measurement and this angle measurement and this side measurement, there's only one way for me to make a triangle out of this, and that's by moving these together. And the only way this can become, sorry, let me got grouped together somehow. The only way that this can become a triangle is if I slide this bottom one close enough that these sides will connect up top there. There's no other option. So with these two, I can't have this side longer. Well, because then this won't match up with this side is a fixed length and this side won't meet there. I need this length to match up to that point. So the only way that happens is if this is close enough so that that top arrow meets that top point right there. So like, and the same thing, that this bottom side can't be too, this is being difficult right now. It can't be too close. These angles can't be too close because then again, this fixed length won't work out. So the only way this works is, everything's ungrouping on me. The only way this works is if this is a specific length so that that matches up, and that means there's only one way to make this triangle with a given angle here, a given angle here, and a given side length here. So that's why it proves triangle congruence there, angle, angle, side. Here's a quick little proof that uses angle, angle, side. BD is the angle bisector of angle ABC. So angle ABC here is being bisected by BD, and when an angle is bisected, it's cut in half. So these two angles, I'm going to call them angles 1 and angle 2. They are going to be congruent to each other. So we have an angle bisector, and 1 and 2 are congruent because an angle bisector cuts an angle into two congruent angles. Ran out of space there a little bit. Try to write smaller than me. And then we have angle A is congruent to angle C. Angle A is an angle of this left triangle, and angle C is an angle of that right triangle. So there's an angle congruence. So we got an angle congruence from the angle bisector. We just were given an angle congruence. And we have a side in common. BD is a side that both triangles share. So that we're going to say BD is congruent to BD for the reflexive property. And that is our side congruence right there. And again, this is not angle, side, angle, because this side is not between the angles. It would have to be this side to be angle, side, angle. This is angle, angle, side. And that's just as good as angle, side, angle. It also works out just fine. So we can say the triangles are congruent because of, I'll use blue. The angle, angle, side of one triangle is congruent to the angle, angle, side of another. So that's angle, angle, side. One more is hypotenuse leg. But before we get to hypotenuse leg, notice that we have side, angle, side we've done. So we saw side, angle, side, and then we saw angle, side, angle. We saw side, side, side. We just now are seeing angle, angle, side. So what are the other possibilities? Well, first, we've seen three sides. Can we do three angles? Can you have angle, 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 congruent, angle, 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 and prove congruency? The answer is no, because think, you can make a really small equilateral triangle. Where's my equilateral triangle in here? Here's my equilateral triangle. I can make a really small equilateral triangle. The angles are 60, 60, 60. And then I can make a big equilateral triangle. The angles are 60, 60, 60. The triangles are not congruent. So three angles congruent to three angles does not prove congruency. It proves something called similarity, but that's for another chapter. So how many ways can you do it with two angles in one side? Here's two angles, one side. Those are the only options. Either the sides between them or it's not. How about two sides, one angle? Well, that's what we have here. Two sides, one angle. And what if the angle's not between the sides? What about side, side, angle? Or backwards, it would spell a bad word. And what I'm going to try to show you here is that this actually doesn't work. It doesn't work not just because backwards it spells a bad word, but it doesn't work because it doesn't work. Let me show you here. So here I'm going to try to do side, side, angle. It's called the ambiguous case because there's more than one way to make a triangle from that information. So the information is that this side is congruent to this side, and this angle is congruent to this angle, and here's another side for us. And what I'm going to show you is that I can move this side to here, and that made a triangle, right? So this, here's the side, here's a side, here's an angle. And then I'm going to make another triangle by actually rotating this a little bit and putting it here. And what you see here is that these two triangles are not congruent. However, they do have a side-side angle relationship. So this side is congruent to this side, and this side is congruent to this side, and this angle is congruent to this angle. But do these triangles look the same? No, they don't. This angle is not the same as this angle. And this angle is not the same as this angle here. And this third side is not congruent to this third side here. So it's not just having any three pairs of corresponding sides proves a triangle. It does have to be in one of these relationships. Having two sides and the angle not between does not work. There are two different ways to draw that triangle. That's why it's called ambiguous, because there's more than one way to do it. So we do have one more way, though, and it's called hypotenuse leg, because it turns out you can kind of have two sides and the angle not between, but only in right triangles. And that's what hypotenuse leg theorem shows us, is that if I know I have a right triangle, first of all, for it to be hypotenuse leg is only right triangles. You only have a hypotenuse if you have a right triangle opposite the right angle. And if I know I have a hypotenuse length and one of my leg lengths, well, then Pythagorean theorem tells us that this third side only has one possibility, because a squared plus b squared equals c squared for right triangles. So if you know this length and you know this length, well, then this length only has one option. And so if I have another triangle that has a right angle, the same hypotenuse, and one of the same legs, well, then the third side has to be there too. So that's what we call hypotenuse leg. Let me show you a quick proof for it. So I'm trying to prove this triangle is congruent to this triangle. First thing I have is L is the midpoint of CB, so we got to run through our midpoint process. Again, like I said, this gets very repetitive. In the beginning, it's really difficult, I think, but after your sixth or seventh midpoint problem, you start to remember how to phrase things. So a midpoint splits a segment into two congruent segments. Sorry if I'm being sloppy. It's not as easy to write on this as it is paper. So that's one congruency right there. Let me mark it on here. There's a side congruency here from our midpoint. And we have CL congruent to BL because of that. The second given was the perpendicular given. And that meant that if this is perpendicular to that, then that's a right angle. This is perpendicular to that, that's a right angle. And so I'm going to angle C and B are right angles, and that means they're also congruent. And now we have our perpendicular process. They are right angles because perpendicular lines form right angles. Again, after you do this for the 10th time, it becomes pretty second nature. Perpendicular lines form right angles, and so they're congruent because all right angles are congruent. And then we are given a third side congruence. AL is congruent to EL. And so this was a side congruence, this was an angle congruence, and this was also a side congruence. But it's not side angle side because the angle's not between the two sides. The angle's not where the sides meet. That would be this angle for these two sides. But it's not angle side side or side side angle because we know that doesn't work because that's ambiguous. But when it's a right angle, when it's a right triangle, we can say that. So this is only available for right triangles, only right triangles. You should never use hypotenuse leg as an argument to prove triangle congruencies unless you have a right triangle. So requires a right angle, which almost always comes from perpendicular sides. So if you're not given perpendicular, you're not using hypotenuse leg. And so we did here, we have perpendicular, so that means hypotenuse legs available to us. So we can say that HL is congruent to HL. And like I said, that's only available because they are right triangles, and they're only right triangles because we have perpendicular, which forms right angles. Okay, so that's hypotenuse leg and angle angle side, and that wraps up our fifth and final congruency relationship. And now we're just going to go a little bit further on what happens after we prove triangles are congruent and some isosceles problems too. See ya.